quiz. So this was a pop quiz related to Unit 1 topic, moles and acid, the first topic of Unit 1. Barium chloride can be prepared by reaction of a barium carbonate with hydrochloric acid. Write an ionic equation for this reaction. So how to write an ionic equation? First, we cancel out the common ion in aqueous solution. So chlorine is common. We cancel out chlorine. And solid, liquid, and gas, we write as it is. So there will be a barium carbonate, which is solid. State symbols are not required, but we can write. Two hydrogen ions are there. Aqueous, it will be ions. Gives a barium ion, which is a group 2. And a carbon dioxide, which is a gas. Solid, liquid, and a gas, we don't change in ionic equation. The only changes happen is for aqueous. Like we cancel out the substance in aqueous solution and we write other as it is in an ionic equation. So this is an ionic equation. Calculate atom economy by mass for this preparation of a barium chloride. So if you need an atom economy, it's a mass of a desired product divided by the total mass of a reactant or total mass of a product into 100. So percentage atom economy is mass of a desired product. Our desired product is barium chloride. And if it was written 2, we'll multiply by 2. If it's written 3, we multiply by 3. Divided by the total mass of either it can be a reactant or the product and into 100. So barium is 137.3 multiplied by chlorine is 35 plus. So 137.3 plus 35.5 multiplied by 2, which will make 71. So this will be 208.3 divided by total mass of a reactant or total mass of a product. It does not make difference because the total mass will be same. So you can take, like if this is 208, carbon dioxide is, we know 44, water we know 18. So we can also do for total here, or we can take the total mass of the reactant, like barium carbonate 137.3 plus carbon is 12 plus oxygen 16 times 3. So that is the total mass of a barium carbonate, and total mass of HCl 1 plus 35.5. But that will be multiplied by 2 because there are 2 moles or 2 molecules, so it should be multiplied by 2. So when we sum the total mass of the reactant or a product, it will be 207, and that should be multiplied by 100. So we get about 77% percentage atom economy. 77.1, you can also write your answer in 3 significant figure. Barium chloride has a melting temperature of 962, where cesium chloride, the same element in the same groups, has a melting temperature. Its chloride is lower. Explain by considering the ions involved, the difference in the melting point of these period 6 chlorides. It's not in the same group. I mean, it's in the same period because cesium is there, cesium, francium. Group 1 and group 2, you're comparing. So first thing, when we compare, the barium will have a +2 charge at group 1, but the cesium will have a +1 charge. So the chloride ion will have a less attraction to cesium as compared to that of chlorine. So +2 charge, which will have a, so we can first, it's a 4 marks. So how you score the 4 marks? First thing, you will compare the charge density or a charge. That is 1 mark. Barium is having a greater charge than cesium. Another thing, as we move across the period, the size of the ion decreases. So barium ion is small as compared to that of cesium. So cesium will be larger, barium will be smaller. So again, this will also have a greater attraction. So barium ion is smaller than the cesium. So as a result, it will have a strong attraction. That this attraction will be stronger. So if the attraction is stronger, we need a greater amount of energy to separate the ions. So it will have a high melting point. So point 3 and point 4 are related to each other. If a strong electrostatic attraction between the ions, so we need lot of energy to separate the ions. So we can simply say that it will have a high melting point. So first thing, barium is having a greater charge than cesium. The second is, you cannot mention here a polarizing effect. The polarizing effect is used to explain a difference between the lattice energy of practical and the standard one, like practical value and the theoretical. Why their difference? That is why you have to use a polarization. They did not ask why theoretical value and the practical values are different. Then you will use the term polarization. But this is two different ionic compounds. So whenever you want to compare, you will compare the charge and the size. Charge should be smaller and charge should be greater and the size should be smaller to have a strong electrostatic attraction. Covalent and ionic bondings are the extremes of continuum of bonding type. Explain the difference in the bonding between a barium chloride and beryllium chloride. Use electronegativity difference. Remember, using electronegativity difference, we can predict that whether it will be an ionic or a covalent. When, as you can, if the greater electronegativity difference is there, then it will be likely ionic. And if it's a small electronegative, like it will have a greater ionic nature. And if it will have weaker, smaller differences there, then it will have a covalent. Like not 100% ionic, it will be a covalent nature. Yeah. So this continue where you left. The structure questions. We'll start in 15 minutes. So both of them, metal and a non-metal is there. So when we talk about a barium and a chloride, this is 0.9 and this chlorine is 3. So electronegativity difference is 2.1. Sit this side. Sit here. Here you can sit. But for beryllium chloride, beryllium is 1.5 and a chlorine is 3. So the electronegativity difference is 1.5. Both have a greater difference in electronegativity. So both of the compounds likely to be ionic, because when electronegativity difference is about like more than 0.9 is there, you can say that likely they will be ionic. But when you compare, it has a greater electronegativity difference, so it will have a percentage ionic nature more as compared to beryllium chloride, which will have a lower percentage ionic nature, or like more covalent nature, covalent character. You can say beryllium chloride having a greater difference in electronegativity, so it will have a like greater ionic nature as compared to that of beryllium chloride. Barium chloride react with group 1 sulfates. A solution is made by dissolving 7.98 gram of a group 1 sulfate to deionize water. Excess of a barium chloride was added in a precipitate form. The mass of a barium sulfate is 10.7 gram. Identify the group 1 element. So first we have to work out the total mass of this compound, and then we subtract the mass of a sulfate and we'll work out what is the element. So first 10.72 grams of a barium sulfate, this thing. So first we'll work out the moles. How to work out the moles? Moles equal mass in gram over molar mass. So first the moles of barium sulfate. Mass in gram is 10.72 and the molar mass of mass of 1 mole 137.3. Sulfur is 32.1 and oxygen is 16 multiplied by 4. This will give us the moles of barium sulfate, which is 0.045. So we get the 0.045 moles are there. Now using this, we'll work out the moles of this compound. How to work out the moles? M is any element is there, group 1 element, M2SO4, and barium sulfate, the ratio is 1:1. So if we have 0.045 moles, so how many moles of this X? We get the same answer. So the moles of this compound M2SO4 are 0.045. So we got the moles as well. Now we will work out this is the total mass of this compound. These are the total moles of this compound. And 7.98 gram is dissolved, like the total mass of this compound which was dissolved in the substance. And how many, so like this is a total mass of a compound. So it contained 2 moles of this group 1 metal, and it contained 1 mole of a sulfate, because it is written M2SO4. So when it will break down into ion, it will produce 2 group 1 ion, and it will produce 1 sulfate. So how many moles of sulfate are there? This will be like 0.045 multiplied by 2, and this will be 0.045, because 1 mole of sulfate is produced. And this 1 mole of a sulfate, what is the total mass of sulfate? So like this is these are the moles of sulfate. How to work out the mass of a sulfate? Moles multiplied by molar mass. So sulfur is 32.1 and oxygen is 16 multiplied by 4. So when we multiply, this will give us a total mass of the sulfate, which is 4.41. So 4.41 is a mass of a sulfate. So how much the mass of the metal is there? The total mass of this compound in the beginning of the question, it is 7.98. So if the 7.98 is the total mass of this compound, and out of 7.98, 4.41 grams of sulfate is there. So what is the mass of this metal? So 7.98 divided by this value, the total mass of this compound will be 3.56. So we got 3.56 gram, and this 3.56 gram is a mass of 2 moles. So what will be the mass of 1 mole? The mass of a 1 mole will be half of it. Like, because according to the question, 3.56 is a mass of 2 moles. So 3.56 divided by 2, you will get 1.78. So 1.78 grams is a mass of 1 mole. And this will divide it by the moles to get them, because we have the formula that moles equal mass in gram divided by molar mass. So if you need the molar mass, so molar mass is mass in gram divided by moles. So mass in gram is 1.78 and the moles of this compound are 0.045. So this will give us the molar mass of this compound, that is 38.8 grams. So 38.8 is a molar mass or a gram per mole. So which element is having a 38.8 gram? That is for potassium, because like potassium is 19 and 39 is there. So it means that this element which is attached here with sulfate is actually potassium. So this element which is attached here is potassium. So first what we did, we got the moles of barium sulfate. From moles of barium sulfate, we work out the moles of the group 1 metal compound. And this contain 1 mole of a sulfate and 2 moles of the metal. And first we work out the total mass of the sulfate present in this, and we subtract to get the mass of the metal. The mass of the metal is 3.56, which is for mass of 2 moles. So mass of 1 mole will be 1.78. Mass of 1 mole divided by moles, we'll get the molar mass, which is 38.8, which is also refers to the mass of potassium, which is 39. So the element which is present here is potassium. In question 2, a multiple choice question, 1 kilogram of a seawater contained 64 milligram of bromide ion. What is the concentration in ppm? So we should have the same unit, because here we don't have the same unit. Concentration in, if you need the concentration in parts per million, concentration in ppm is a mass of solute divided by the mass of the solvent into 1 million. So, but this is given in milligram, so it will be 64 milligram. We divide by 1000, so 64 gram. And seawater is in kilograms, so we multiply by 1000. This will now be in gram. Or you can also write like multiply by 1000 or 10 power 3. And then multiply by 1 million. So this actually like 10 power 3, this will become 3, and plus 3 and minus 3. So they also cancel out. So you are only left with 64. So the concentration of bromide ion is 64 ppm or parts per million. So concentration in ppm is mass of a solute divided by mass of solvent into 1 million. They should have the same units. How many bromide ions are there in 500 gram of a sample? So 1 kilogram contain this much bromide, like 1 seawater to bromide ion ratio. 1000 contain, like, because 1 kilogram means 1000 gram contains 64 into 10 power minus 3 gram. Milligram I convert into grams. So in the question, if we have 500 gram, how much it will be x? We just cross multiply. This will give us the moles. Sorry, this will give us the mass in gram. So it will be 500 gram means it will be half of it. So this will be 32 into 10 power minus 3 gram. And this 32 into 10 power minus 3 multiplied by the divided first. Now we'll get the moles. This is a mass of a bromide ion. If you need the moles, mass in gram over molar mass. So bromine average mass of the two isotope, you can take 80. So it will be 32 divided by 80, which is 0.4 into 10 power minus 3 mole. And this 0.4 into 10 power minus 3 multiplied by Avogadro's constant. So to get the number of the ions, multiply by 6.02 into 10 power 23. So it will be 6 multiplied by 0.4, which will make 2.4. And 10 power 23 multiplied by 10 power minus 3. So this will become 10 power 20. So in that case, A will be the right answer. So first we work out the total, and then we multiply by the, first we work out the mass in 500, then we work out the moles, and then multiply by the Avogadro's constant to find the number of the ions. The next question, 0.15 moles of aluminium is added to 120 cm cube of 1 mole per dm cube hydrochloric acid. The amount unused reactant is, so we have 0.15 moles. So first we use the concentration into volume. We got the moles, which is in this case is 120. So 120 divided by 1000, which is 0.12. So 0.12 multiplied by 1.5. So 0.12 multiplied by 0.12 times 1.5, that is 0.18. So 0.18 moles of HCl. Now the ratio between them, ratio between aluminium is 2:6. Like 2 aluminium are reacting with 6 hydrogen ions. So if we have 0.18, how many moles of aluminium are needed? X. So it will be 0.18 multiplied by 2 divided by 6. So we need 0.06. For a complete reaction, we need 0.06, but we don't have 0.06. We have 0.15. So like we have 0.1, we need only 0.06, but we have only we have 0.15, so means we have more than what we need for a complete reaction. So which reagent is in excess? So in this case, aluminum is in excess. And because like this, these are the moles which reacted, we have more than what we need, so aluminum is in excess. So how to know how many moles are left? So it will be the original moles minus the reacted, which is 0.06. So we get 0.09 moles of aluminum which are unused or unreacted. So first we work out the moles of HCl. From moles of HCl, we work out how many moles of aluminum are required. We need only 0.06 and we have more than that. So it means aluminum is more than enough or in excess. So the total moles minus the moles of aluminum which are reacted, we get how many moles are unreacted. Organic compound is there. You have carbon, hydrogen, and oxygen and chlorine. 24.2, 4, and 71.8. The first step for finding the empirical, divide by atomic mass 12, 1, and 35.5. So 24.2 divided by 12. So 2.017, this will be 4. And the last one is 71.8 divided by 35.5. So this will be 2.02. Then we divide by the smallest value, 2.017, 2.017, and 2.017. This will be 1, this will be 1. And 4 divided by 2.017, that is equals to 1.98, which is approximately 2. So 2 hydrogen, so then 1 carbon, 2 hydrogen, and 1 chlorine, so it should be B. And the last one, which solution contain the smallest number of the ions? So first, what you have to do, you have to do the concentration into volume multiplied by concentration. And then how many ions are there? It contains 1 calcium and 2 nitrates. So the final answer will be multiplied by 3. Here, volume and concentration, you multiply, you get the moles. And then how many ions are there? 1 potassium and 1 iodide. So multiplied by 2. The final answer. Here, volume into concentration, you get the moles. And how many total ions are there? 2 chloride ions and 1 barium. So it will be 3. Here, volume into concentration, you got the moles. And how many ions? 2 ammonium and 1 sulfate. So this will be multiplied by 3. So you have to multiply like, the one which will give the highest number, in that case, D will be the right answer.